welcome to the notes on 8-2. This is special right triangles. I hope you've been practicing your perfect squares list. Remember that you have a no calculator memory quiz on February 4th or 5th, depending on whether you're A or B day. Page 5 and 6 in your unit guide will help you study for that. Make sure that you are prepared. Notes start on page 17. Special right triangles are really just a shortcut for Pythagorean theorem for two special types of our right triangles. The first one is a 45, 45, 90 degree right triangle, and this triangle is isosceles. We know this because two of the base angles are congruent. They're both 45 degrees. In class last time we did an exploration with this, and we found that for our basic triangle with side length of 1, if we use the Pythagorean theorem, we find out the hypotenuse has to be square root of 2. So when my side lengths are 2, we can either count 1 square root of 2, 2 square roots of 2, or we can use the Pythagorean theorem and find it that way. Pattern starts to emerge. We've got 3, 3, 3 square root of 2, 4, 4, 4 square root of 2, and so on. Well, we can extend this to a general pattern. If we have a 45, 45, 90 right triangle with side lengths of n, the two congruent sides would both be n, and we would expect that our hypotenuse would be n times the square root of 2. That makes it really easy to solve triangles like that because we don't have to work them out. So for this first one, if the leg is 5, our other leg also has to be 5 because these are both n's. The hypotenuse is our n square root of 2, so this is going to be 5 times the square root of 2, or better written 5 square root 2. This next example is a little bit different. If we think about our side lengths, this is n, and this is n square root 2. Well, I don't know my n this time, but I can set up an equation using this information. I can say that n square root of 2 has to be 8. Solving for n, I would divide by the square root of 2, and I get 8 over the square root of 2. But if you remember from Algebra 1, we don't leave radicals in the denominator, so we're going to rationalize this. To do that, we multiply by a clever form of 1, and I'm going to use the square root of 2 over the square root of 2, because that is going to allow the bottom to become a perfect square. So I would have 8 square root of 2 over the square root of 4, which is just 2, or 4 square root of 2. This is my n value, and so these two sides would both have the length of 4 square root 2. Now let's move on to our 30, 60, 90 right triangle. If you remember from the exploration, each of these dots forms equilateral triangles. So this angle would have to be 60 degrees, and we're going to call each of these a side length of 1. Again, if you remember from the exploration, we found that with our basic triangle with a side length of 1, if this is our 60 degree angle, this is 1 plus 1, making our hypotenuse have a length of 2, and Pythagorean theorem gives us that other side length, x squared would be 3, so x would be the square root of 3. So what we learned from that is a vertical measurement has a length of the square root of 3. So if this side is 2, we can simply count 1, 2, 3, 4. That has a length of 4. This is 2 of those, so this would be 2 square root 3. You can also use the Pythagorean theorem to derive that length. So if I have 3 here, we can count 1, 2, 3, 4, 5, 6, and 1, 2, 3 of those vertical square root of 3. And finally, we have a horizontal length of 4, hypotenuse of 8, and then our vertical length would be 4 square roots of 3. So again, like with our 45, 45, 90 degree triangle, we can develop a general rule. It's key to pay a little closer attention to these because your 30 degree and 60 degree angle don't match. You have to make sure that the side you label N is across from your 30 degree angle. And then if you remember, your hypotenuse each time was twice as long as your base horizontal. So this is going to be 2n. Our vertical, we were counting by square roots of 3, so this is n square root 3. So let's look at an example here. In this case, they're showing us the 60-degree angle, which means this is my 30-degree angle, and it means this side is n. This is my 2n, this is my n radical 3. So since n is 4, I know that this side would be 8, and this would be 4 radical 3. That's a very straightforward application of your special right triangle. So let's look at this next one. Actually, we're going to jump to the third one, and we're going to come back to the one in the middle. So if I look at this last one, I'm doing my labels. This is n, this is 2n, this is n square root 3. So they didn't give me n, so I can use this equation to figure out that n is 7. You can also just recognize if 2n is 14, n would have to be 7. So the length of FE would be 7. Now that I know n, I can apply that over here and find out that DE would be 7 square root 3. So now let's look at the one in the middle. Start by identifying your sides. Because it's across from 30, that's my n, this is 2n, and this is n square root 3. So they didn't give me n. I'm going to set up an equation that says n square root 3 equals 9. And then we're going to solve. To do this, all we need to do is divide by the square root of 3. And so then we have n equal to 9 over the square root of 3. Just like we did in the last one, we're going to need to rationalize. Use that clever form of 1, square root of 3 over square root of 3. So we get 9 square root 3 over the square root of 9, which is 3. And this simplifies to 3 square root 3. So the missing side length, FE, would be 3 square root 3. Once I know that, it's an easy thing to find your hypotenuse. All I need to do is multiply that times 2. So for my hypotenuse, that's 2n. So it's going to be 2 times 3 square root 3, which would be 6 square root 3. So this side would be 6 square root 3. The key to these is always finding the side that you have labeled as n before you try to find any other sides, because all the other sides are calculated based on the side labeled as n. Let's go ahead and turn to the next page, and you've got some practice problems. I want you to try to do these on your own. Turn off the video, and go through this first example. This is a fairly straightforward example, except for the fact that you've got 2 triangles. You're going to need to work through each one. Clearly, you're going to want to start with the 30, 60, 90 triangle on the left, because that's the only one that gives you a side length. So we'll go through and figure that out. Stop the video, see if you can figure that out, and then resume the video to check it. Okay, hopefully you got that. I'm going to look first at the 30, 60, 90 triangle that they gave us, and I'm trying to redraw it so it maintains the same orientation. But if this is my 30 degrees right here, that means this is n. Across from my right angle has to be my hypotenuse, so that's 2n, and my longer side is n square root 3. What they gave me was a 3, and that was right here. So this one's not bad because they gave me my n value. So 2 times n would be 6, n times radical 3 would be 3 radical 3. So I'm going to go ahead and transfer that information over here. This is my 3 radical 3, and this side is 6. Well, since my triangle doesn't change, I can now pull off the second triangle. And if this is 45, that means it's a 45, 45, 90 right triangle. So this is n square root 2. And then I'm going to pull over that 6 that I just found, and it's right here. So if that's 6, this is also 6, and this would be 6 square root 2. So my other two sides would look like this, and we have now found all of our sides. Now let's take a look at the next one. You are missing on mark right here. This needs to be told that that's a right angle. And I want you to go find the missing sides. Primarily, we're going to be looking for this side right here and the total length down here. It may help you to separate the base into two segments because we do already know part of it. Stop the video, give this one a try, and when you've got an answer, resume it so we can take a look. Okay, if it were me working, the first thing I'm going to do is kind of separate this off, and I know that this piece is 30. So now what I'm looking at is this 30, 60, 90 right triangle. Well, I can carry over this 10 because that's the same length. The side across from 30 is n, hypotenuse is 2n, the other side is n radical 3. So if n is 10, this side has to be 20. Let me write that. And then this side would have to be 10 radical 3. So we've now found this side up here to be 20. We have that answer. And this side is 10 radical 3. So the length of the total length of that base, because 30 doesn't have a square root on it, we can't add those. We would write 30 plus 10 radical 3. All right, last problem is a word problem, so it's going to help us to make sure that we understand it and draw it. So read through the problem, pause the video, try to draw it, and label that. The only thing that you need to make sure you recognize here is this is a 30-degree angle with the ground. So stop the video, read through the problem, and draw it. Then turn the video back on and make sure your drawing fairly matches mine. Hopefully you have something like this. Surely not quite this artistic, but you've got the idea. We have a 30-degree angle with the ground for our ramp, which has a length of 12 radical 3. This is my right angle, so this has to be my hypotenuse. The side across from 30 is n, hypotenuse is 2n, the third side would be n radical 3. They didn't give us n, so we're going to set up that equation to figure that out, and we know that 2n is 12 radical 3. So all I need to do is divide by 2 and find out that n would be 6 radical 3 units. Okay, so the height of the truck from the top of the truck to the ground would be 6 radical 3. But this is asking us the distance from the base of the truck to the end of the ramp. This is n radical 3. So n radical 3, since n is 6 radical 3, would be 6 radical 3 times radical 3, which would be 6 radical 9. Square root of 9 is 3. So we get 18. And this would have a length of 18 units, whether that's feet or inches or probably feet since it's a truck. At this point, you've reached the end of the video, so it's time to go on and do your Tier 1 and your knowledge check.